As an engineer, if you want to learn Simulink and you want to apply Simulink knowledge to develop a real world application, or you want to test your real world softwares, here is the video which can help you. In this video, we will be explaining how to develop a simple model and how to add different blocks inside that model and how to test that model. Hello all, welcome to our YouTube channel. First of all, Simulink is a very advanced tool where it is useful in all kind of real world engineering applications, from testing to software development and software simulations in all applications. Have you ever heard words like mill, sill, hill and pill? Want to know actual application of these terms? Then we'll explain one by one how it is done using Simulink. First of all the software developments or any developments should be done in a C code or in a X code. Means system or a controller will only understand C code or X code. But for a human to develop this software, the different coding languages and different coding platforms are available to make the job easier. Same way, MathWorks has developed Simulink to do a user friendly development application, that is Simulink. In Simulink, we will be adding the blocks which have internal C code to those blocks, and with that connecting this block to develop a application where this application is tested in a closed environment in a simulation. So with this, all these models will have internal C code, and this C code can be understood from the controllers. For that reason, a user friendly models can be developed, and then C code will be converted out of this model, and this C code will be flashed to your controller for your real world application. That's a quick introduction about the application of Simulink. Now let us start into the software. To begin with, how to open the software. Once search for your MATLAB in your PC. One just after the installation, you will have this window opened where MATLAB version window will be opened, and then here you can see multiple tabs like home, plots and apps, and within home tab you can see multiple widgets. 2023b version installed. So if you have latest version, current latest version is 2025b version, which is applicable for usage. For using the Simulink application, we can directly start clicking on the Simulink. Just after clicking the widget, a window will be opened where you can see options to select blank model, blank subsystem, blank library and blank project. So if you are working in a project team, then you will be having this blank project option that you can select, where you can create multiple models and multiple subsystems, and each project members can use this project and can run that simulations. So for that reason, you can create a blank project. Otherwise, if you are just creating a simple model, then you can just start with a blank model option. And there is another option where subsystem. Subsystem is if you want to create any particular part of a model where if you want to reuse multiple times, then you can create this subsystem. And this is like a for methods which you will be using in your C code. Methods will be called in the main program now n number of times. That way these subsystems also can be repetitively called in your main program. And then coming to blank library, it is similar to subsystem, but major difference is this blank library cannot be edited from other users. For example, if you have created any blank library, any library function, and that library function somebody wants to use, he can only use that library function, but he cannot modify the functions of that internal to the library function. That is the advantage of creating a library. When coming to blank subsystem, it is just like if you have created a subsystem and somebody wants to use this blank subsystem, then that person also have access to modify that function of that subsystem. So this is the major difference between subsystem and library. And there are other options. Code generation is once the model is developed, then you can convert it into C code, so that this directly this C code or X code can be flashed into your controller. That is the application of this code generation part. Now we'll just simply start with a blank model application and we'll create a blank model. So once you click a blank model, you will have this window open with untitled page. Here you can explore many options. First, start to start with, you have a library browser. So in library browser, you have multiple options. I have currently installed many toolboxes. Toolboxes are the special library browsers already functions available in your MATLABs and Simulink functions. So for Simulink, by default, you will have this kind of these many library functions, and in this particularly you can go through one by one, which can be useful for your application. When you commonly used blocks, you will have a bus creator and bus selector. Bus creator is like a demux, and bus selector is like a multiplexer. Bus creator will do, like, if there are n number of inputs, it will try to select n number of inputs to one output. Bus selector will do opposite. It takes one input and it will produce n outputs. So this kind of functions are available, and it's a constant function. Constant function is a just a block to add remove any constants in the model. Then data conversion, if you want to convert one data type to another data type, then you can use this convert option. From integer to float, integer to string, integer to character, the conversions can be done using this block. Delay block is a special block where if you want to produce a delay in calculation, means if you want to take one raster previous to your previous calculation, then you can use this delay block. Demux is similar to your, again, bus selector. Then coming to discrete time integrator, it's an integrator function. And again, there are two types of integrator, with a simple integrator and this discrete time integrator. This discrete time integrator is a special integrator where you can define the derivative of that integral interval and you can do the integration. That is one advantage of this discrete time integrator. And this integrator is a continuous integrator. It can be used in any kind of integration functions with respect to time. So there are many other inputs which we can explore, like product block, which will do the product of the inputs, and then saturation block will produce an output saturating to the limits produced in this block. And then switch block is like a general switch case block where based on your input condition, a particular input will be selected using the switch statements. So these are the commonly used blocks. And coming to continuous blocks, it's like based on your type of equations and type of calculations, if you want to use, you can use explore this continuous blocks. Generally all of these are majorly used in control system applications. And this dashboard is a special automotive application toolbox where you can create what you want to display in the Simulink. This is for just for user representation. You can use this blocks. Same way, you can explore this kind of functions in library browser. So rest of them you can, based on your application, you install your toolbox, and then if you have the license for the toolbox, you can start using those library functions. Mm. Let's start building our simple model, and let us explore what we can do from this model. Now we'll start with a simple example where it's based on a simple Newton's equation. F is equal to MA will develop a function where two inputs are there, mass and acceleration, and you are calculating the output force required to move that block. This is a simple calculation which we will build in this MATLAB, and then we'll try to use some functions and we'll try to get some application from these special functions. Okay, first you have to you are doing the product of m into a, so we'll take a product block, just double click and you will get the search option, and then select for product, get the product block. Then you want to feed two inputs, one is mass and another one is acceleration. For example, you want to lend if you want to send the mass value directly with some constant value, you can take a constant block. You can directly search, or you can also browse in library browser also. You can search for the names here also. Similar and better options can be available once you do the search operation. And then you want to feed one more acceleration, but I don't want to take the acceleration directly from a constant block. I want to compute this acceleration by generating the actual acceleration out of velocity. Acceleration is a dv by dt. We'll differentiate this d velocity and we'll try to produce the acceleration. You can search for a block derivative and you can produce the derivative out of the velocity input. And we'll take a step input for velocity for change in time, where we'll change step time as 0.05, initial value let it be 0, and final we'll keep it to 10 kmph, 0.01. This will give it to velocity, and then this, and mass will keep 5, and we'll write it as mass, and here we'll write it as, and then we'll display these results in a scope. Is a window where you want to display the results, and you can graphically analyze what kind of behavior is there for that system. Now let us run the system and we'll understand what kind of behavior is there. Now we have built a simple force equation based model where for F is equal to ma we are evaluating with mass of 5 kg and velocity of this input 0 to 10 step input, and that you are differentiating with a differentiator block, and you are creating a product and visualizing in a scope. That is what we have built a model, simple model, just to understand how to use the blocks and how to create a simple system. Then next, to run the simulation, you have to just go to simulation tab, and you will have this run widget. In this run widget, there are many drop down options like run all, simulation pacing, run run option. We can directly use the run option. If you are having multiple projects, then you can select particular models to run what kind of models. If you want to get the simulation results, those kind of models will be selected and that can be ran. Next, there are other options like normal. If you if you just select the drop down, then you will have normal accelerator and rapid accelerator. In normal, you will just do the normal simulation with whatever the inputs available at that runtime. All these inputs will be used and will be produced an output. Coming to accelerator, accelerator will use the previous simulation results and previous simulation outputs and will do quick simulation. That is accelerator. Rapid accelerator is a one of the option. This option we can, I'll explain it with example with one of the use case, where if you want to develop an application for controller in loop or software in loop, for those kind of application you will be using this rapid accelerator. We'll be understanding that in upcoming videos. Same goes with this fast restart. Fast restart is also similar option, where if you want to have an application where if you want to use the previous simulation results, and that too if you are developing the particular test cases where all the test data from the some part of the model if you want to utilize, and it's only some part of the model you have to execute, then you can use this fast restart option. So now let us just simply run the simulation. Once you run the simulation, the results you will be obtained in this scope option, because you are putting all the results in the scope. There is one warning which it is showing, view one warning, and the warning is with respect to the model name is not saved with anything, so that is the warning. Any errors in this block diagrams will be also seen here. So this is the diagnostic viewer or diagnostic window, we can say. Now if you just click on the scope, you will have this scope open like this. There are multiple analysis tools available here. For example, this is a zoom x, where if you want to zoom particular time zone, then you can use this zoom x. And if you do the drop down, there are zoom options available at vertical axis also, where if you want to zoom y axis, then you can use this. And then you have, if you want to fit the time scale or the y scale, then you can use this option. Then later there is an option called cursors. By selecting cursor and just tapping on the screen wherever you want to see the measurement points, those points can be made visible on the right side. What is the value and what is that difference in that value with respect to two cursors, all those analysis can be done. And also one advantage is both time domain and frequency domain analysis are given. That is one good advantage of this cursors. So that's about the graphical analysis. So currently we had built a small model just to give the small idea of Simulink modeling. Later we'll be going on further use cases of Simulinks with good practical examples. So stay tuned and follow our YouTube channel. If you have liked this video, please like, share and subscribe.